Okay, so I'm going to do 5. I'm going to take it to another piece of paper because it'll definitely require some more space. Okay, so on number 5, it looks terribly ugly. They're telling us we have some function f of x and another really ugly function g of x. And then they're telling us that we have some function that we don't know, h of x. They don't even give us the equation for h of x, but h of x is sandwiched between f and g, so it falls between those two. And then it gives us this extra information, and it's just saying h is in between f and g only on the interval from x equals 2 to x equals 4. So it may not be always, but because we're considering 3 falls within that interval, so we're good. So other than that, I'm not really going to worry too much about the fact that they gave me the interval. So we're trying to evaluate the limit as x goes to 3 of h of x. So I could take this inequality. So this is a sandwich theorem question. This is the inequality that they're telling us is true on the interval we're concerned with, which is near 3. I'm just going to add this limit in front of all 3 of these. So I'm going to add the limit as x goes to 3 in front of f of x, and I'll add the limit as x goes to 3 in front of h of x, because if the first statement is true, then this statement must also be true, because I'm doing the exact same thing to everything. Okay, and they told us this statement was true, that was given. So again, if this statement is true, this must also be true. So now it comes down to, can we evaluate each of these limits on the end? Well, because they gave us the function f of x, we could evaluate this, or we can try anyway. We take the limit as x goes to 3 of f of x. F of x is 6x minus 18 over x minus 3. How would we go about evaluating that limit? What do you guys think? Can I do direct substitution? Can I plug 3 in?
Factor it first.
Very good. Factor it first. 3 would make it be undefined. The numerator, we could take out a 6. So it'd be 6 times x minus 3. And that works out fantastic because we wanted to remove that discontinuity. So we really just have the limit as x goes to 3 of 6, but that's just 6. So this left-hand side is 6. I still don't know this thing in the middle because they didn't even give us the equation to figure it out. So I have no other option than to like sandwich it in between the two things that are given. That's what I'm trying to figure out. But now I'm going to come to the other side. Let's see if we can evaluate this limit. They did tell us g of x. They told us g of x was right here. So we have the limit as x goes to 3 of this terribly ugly function, pi x over 6 divided by cosine of x minus 3. So even though it looks terrible, we always start by just trying direct substitution. So I'm going to plug in 3 and hope that I get some number out. So if I plug in 3, I'd have 6 sine, let's see, that would be 3 pi over 6. And it's divided by cosine of 3 minus 3. But 3 minus 3 is just 0. So I'm just going to go ahead and say the denominator is cosine of 0. What is cosine at 0? You can think of it on the unit circle. 1, very good, because at this point, that point is 1, 0, and cosine goes with x. You could think of the graph. You want to get to where you can do these pretty quick, but at 0, it's 1. So whichever way you do, unit circle or that, it's 1. That's a good thing. That means we don't have to like factor or remove any discontinuity as long as the denominator doesn't equal 0. So then on top, I'm looking at this and I'm saying, okay, well, I could reduce that to pi halves. Pi halves would be this point. So that coordinate is 0, 1. Sine goes with y. So that value is 1. This is really 6 times 1. So the numerator is 6. So that side is 6. So that means this limit is 6, which is fantastic. We just proved that this thing that we don't know is sandwiched in between 6 and 6. So what can we conclude about this limit? We could say the limit as x goes to 3 of this unknown function that we don't even have must equal what?
6.
6. Thank you. Now, you might think, well, what would we have done if they didn't equal each other? It wouldn't have been possible. So on a sandwich theorem question, you kind of know where you're going, right? You know that this side and this side better be the same. If they're not the same, something probably went wrong because there would be no way for us to figure it out. Okay, so that was question 5 on sandwich theorem. The other question is another sandwich theorem question, number 6. So on number 6, sandwich or squeeze theorem, you can call it either one. we have the wording on this one is different because they're telling us we have some function f. So the only function we know is we know this one. On the previous one, they told us like both of the outside functions. They didn't tell us that here. They just told us f of x for all values except for -2. Not really surprising because if x was -2, this would be undefined. So we don't have to do much with it, but that's why they're specifying that. If the limit as x goes to -2 can be found using the squeeze theorem, so this goes back to what I was saying. If we're going to be able to use squeeze theorem, then that means I could squeeze this limit in between the limit of the two other sides. So again, I'm just basically taking this that they gave us, and I'm writing limit as x goes to -2 in front of each piece. So I'm just going to write limit as x goes to -2 of f of x. That must be smaller than the limit as x goes to -2 of the bigger function. So we know that this statement must be true. They told us that this side, did they tell us? Oh, they didn't tell us, but we know this function. So we can evaluate this limit. So this limit, the limit as x goes to -2, they gave us the f of x function. So I'm just going to take the limit of that function. Can we plug in -2? No. So we factor. The numerator can factor as an x plus 2 and an x minus 2. So the x plus 2 can cancel. So this side reduces to the limit as x goes to -2 of x minus 2. Can we plug in -2 now? Right, we're good. So we're going to get -2 minus 2, so that side is -4. So we were able to evaluate this one. That's the only one we can evaluate because that's the only function we have. We can't evaluate anything else. But that means that the limit as x goes to -2 must be sandwiched in between because h was in between these two functions. So this is as far as we can really get with this question. We know that this statement must be true. And what the question is saying is, if it's possible, so if we can find the limit as x goes to 2 of h of x using the squeeze theorem, then what does the limit of the bigger function have to be? What does this limit have to equal so that we could figure out what the middle one is?
-4.
-4, exactly. It's just the idea that the only way squeeze theorem is going to work is the limit of the bigger function and the smaller function have to be the same number. So the only way it would work is if that function was -4. So that's all we have to say. So you would say, so it can be found. So the limit as x goes to -2 of j of x must equal -4. And the logic is because the unknown had to be sandwiched in between two things that we know, and they had to be equal to each other. Not too bad. Okay, let's look. So that was your assignment from last night. Did everything else go okay? You have other questions now, okay? I'm gonna go ahead and go on then. This one, all we have left is really short. So your 1.5b assignment. These ones though take us back to how we started limits, so it's kind of nice. It's a good review getting ready for our test, but they make them look really tricky. For the most part, they're okay, but sometimes they do get a little complicated. In general, so if I ignore the graphs for a second, what's our first step whenever we try to do a limit? What's our first thing we try?
We would plug in the 3.
Exactly. Yep. So we call it direct substitution. So the first thing we're going to do is we're just going to, everywhere there's an x, we're just going to replace the x with a 3. So both of the x's are just going to become a 3. We try this before we have to do anything else. So everywhere there's an x, we put the 3. And then we can use the graph to try to evaluate this. So when it says f at 3, that's asking for the function value on the graph of f when x equals 3. So f is this first function. So I'm going to go to x equals 3. So 3 is here. I go up to the function and I find the value of the function. So f at 3 is that y value. That y value is 3. So the numerator would be 3 quantity squared. Not too bad. The bottom, they want us to find g at 3. This is where function notation is a lot better than just like y, right? So it's telling us to look at the graph g. So here's the graph g. I go to x equals 3. I go to 3. And I just want the y value. Well, the y value at that point is 2. The denominator is 2 plus 1. You could leave your answer like that, or I could just say 9 over 3, and 9 over 3 is 3. So before you try anything funny, you always just try direct substitution. Not too bad. Okay. Okay, let's look at 6. 6 asks us to take the limit as x goes to 2.5. So it's kind of weird because it's a decimal, but I'm going to try the same approach that I did on the last one. The approach is you just are going to replace x with that number. So I'm going to just try writing it out. This would be g of f of 2.5. And we just work our way from the inside out. So now we have to evaluate the function at 2.5, the function f. So we look at the f graph, which is the first one. So looking at the first graph, we go, okay, 2.5. 2.5 is right here. What is the value of the function f at 2.5? What's the y value? 3. Yep. So this is really just g at 3, because the inside piece became 3. But now this is saying, okay, go to x equals 3 on the g function. So we look over at the g function. At the g function, x is 3 is here. What's the y value there? 2. So our answer, 2. So those ones really aren't too tricky. Take a second, try 7 on your own. Okay, 7 is more tricky, but I want to have you think it through first by yourself. What kind of answers do you guys have? What answers do you think it might, what do you think it might be? Anybody have an idea?
Is it does not exist?
Does not exist. Anybody else think that could be it? How about any other answers? Does anybody have a different answer you think it might be? Everybody's thinking does not exist.
If it's does not exist, is it 3?
3.
If the answer is does not exist.
That's another thing it could be. So I like that you're talking about it. So maybe does not exist, maybe 3. Turns out it's not either of those two, but that's what I thought too the first time I looked at this question. I at first thought does not exist, so I understand that logic. And then I thought, okay, it must be 3. And then I was like, oh, I keep missing it. So let me explain why this one is a little bit different. So we plug in the 3, but here's where you would think that it does not exist. Because if you plug in 3, you'd have f at g at 3, right? And then g at 3 from the table is g at 3 was 2, so then you had f at 2. But the problem with f at 2, if we're taking a limit, it would make sense that you say it does not exist because at 2, the two sides don't equal each other. So yeah, that was my first thought with does not exist. I'll explain why it's not that. Then the other answer that I heard was 3 because it's the filled in circles. You might think, oh, well, it's just that point. Turns out both of those are a little bit off. Now, here's the reason for that. When we do direct substitution, when we run into this weird thing, what I'm really doing is I'm taking the limit of the inside function. So I'm going to kind of think, okay, I'm taking the limit of g of x as x goes to 3, which is 2, except for as I think about this, if I take it as a limit, as I approach 3 from each side, we're approaching a y value of 2, but in both cases, we are approaching 2 from below. Would you guys agree with that? On the graph of g, as g approaches 3, both sides approach 2 from below. So what that means is, yeah, that's 2, but when I take the limit of f, I'm taking the limit as x approaches 2, because that was the y value, like that's the value we would plug in. But I'm going to put a little negative right there because I'm approaching from below. So really, when I take the limit of g, because I'm approaching the y value of 2 from below, now I'm taking the limit as we approach 2 from the negative side. That negative is indicating from values just less than 2. So like, if I was at 2.9, right? If I was at 2.9, I would have a y value of like 1.9 or something like that. If I was at 3.1, I would have a value at 2.1. So since the limit doesn't exist at 2, I wanted to consider, well, what would it be on each side? Oh, sorry, not 2.1, right? This y value over here on this side is still less than, so that would still be a y value of like 1.9. Both of them are y values just less than that. So when I'm approaching 2, I'm really approaching 2 from the negative side. So that's why this answer is -1. You had to know which side to approach from. Yeah, Hayden.
If they had both been approaching from the top, would you do a 2 with the plus?
Exactly. Yep. So you kind of just have to think, if the limit doesn't exist at 2, so that's my initial thought would be that the limit doesn't exist at 2, then I would go, okay, wait, am I really approaching from one side? And we're approaching from one side because both y values on either side of that like sharp turn, either side is a number just smaller than 2. So then we look at values approaching from the left. I will say that this is a new thing they've just started asking on the AP test over like the last 2 years. They didn't ever ask questions like this previously. There will be like one weird limit question like this on the AP test. On your test, I'll throw in one of these. They're not going to be a huge like point value thing, but they will come up. So I just thought of one other thing. So I'll tell you your assignment. So your assignment is like 7 through the rest of it. I don't think there were any, but you can skip 22, 23, 24, and I think that's it. So I'm going to write this, but I want to mention one other thing. So this is 1.5b. You guys are doing 7 through, 31, but you're going to skip questions 22, 23, and 24. I want to do one other thing that I just realized I haven't posted on Canvas. So don't log out. We're going to do one other activity. It will take me just like 2 minutes to get started. So see, you can do these on your assignment. Start this, and then I want to do one other thing. Try these first set of questions, and then let's talk about our answers. So try 7 through 14. Go ahead and start your assignment. I'm going to give you guys about 5 minutes to do those, and then let's share answers and see if we all agree with those. Some of them will be pretty straightforward and not tricky, and then some of them will be like that last example. Okay, so I'm going to just mute this, and in 5 minutes, All right. Are you guys good if we talk through these? Okay, I'm going to give you one more minute. I'll give you 30 seconds, wrap up the one that you're working on, and then let's run through like 7 through 14, make sure we're good. Okay, what did you guys put? What is the limit? I'm gonna pick on you guys. I would do this in class, so listen for your name. I'm gonna call on some of you guys. I'm gonna pick on Cameron. Cameron, what did you get for number 7? What's the limit as x goes to -2 on the j of x graph? Are you there, Cameron? I'll come back to you. Oh,
Hey,
you're good.
sorry. For that one, I got infinity.
Exactly. Very good. Yep. Because both sides go up to infinity. This is kind of the weird one where you could give infinity. I think infinity is the most descriptive, but the book and the test would also accept does not exist. So at a vertical asymptote, you could have given either of those answers. Okay, number 8. I'm going to pick on Annie. Annie, what did you get on number 8? It asks for the limit as x goes to 1 on j of x.
I wasn't super sure for that one, but I said does not exist.
You are exactly correct. Yeah, so that one has to be does not exist. And the reason why that's right is because one side goes to positive infinity and one side goes to negative infinity. So very good. Okay, number 9. Number 9 gets a little bit trickier. What do we have to do first on number 9? Anybody, what do you guys think? What do we do first?
Direct substitution.
Yeah, so let's just try direct substitution and we hope everything goes okay so we don't have to do anything funny. So we're just going to plug in -1. So if we plug in -1, we need to find the function value of f at -1. And at -1, it has a function value of 1. So that's 1 minus 2. So the numerator, I get a -1 on top. On the bottom, I need to figure out what j at -1 is. So j at -1 is also -1. Did I write that wrong? You guys, I messed up, right? This is a -1. Right, f at -1, -1. So this should be a -3 on top. Bottom is a -1 quantity squared, so I got a +1. So my final answer would be a -3, so on number 9. You guys agree with -3? Thumbs up if you got -3, if I can see your video. Okay, perfect, thank you. On number 10, okay, we're taking the limit as x goes to infinity of h of j of x. Who thinks they got this one? Who wants to share their answer?
I got 3.
3, perfect. How did you get it?
Because as as j goes to infinity on the x-axis, it approaches 2. So I just looked at
Perfect.
h, which is 3.
Perfect. You guys catch that? So as x goes to infinity on the j function, this approaches 2, so then h at 2 is 3. So great job. 3 is the correct answer. Okay, on 11, who thinks they've got the answer on 11? Who can explain 11?
Hold on. For number 10 on the h of 2 part, how do we decide
Yeah.
whether it's the top one or bottom one?
Oh, good question. Let me look more carefully at that. Good point. Yeah, we definitely need to look at this. It has to do with the fact that we are approaching, when we have h at 2, h approached 2, but it approached 2 from the negative side. So yeah, we approached 2 and we approached 2 from the negative side. So that's why this really becomes the limit as x approaches 2 from the negative side of h of x. So that's why we are approaching on this side. So we're approaching in this direction, which is why we get to the value of 3. So yeah, we did have to consider on which piece we were on.
Okay, that makes more sense.
Good question. Thanks for asking that. I went too quick on that. Okay, who thinks they can explain number 11? Who got the answer on number 11?
Well, I got 2, but I'm not like too sure how I got that.
You have the correct answer, so good work. So let's just see if it works by just plugging it in. If we plug it in, we'd have g of f at -1, and f at -1, if we go to the graph, f at -1 is just -1, and it's -1 from both sides. It's fine, so that's just -1. So then we would have g at -1 plus 1, or g at 0, and g at 0. G at 0 is equal to 2, because it's no longer a limit, because we actually get that value. So I guess this is where it gets a little confusing. When we plugged in the -1 into f of this, f of -1 is equal to -1. Like, it's not that it's approaching, and it's -1 on both sides. So it is exactly that. I don't have to put a plus or a minus sign. So then when we do this, we're looking for g at 0. And g at 0, the value of the function g at 0 is 2. So that's why it's 2. We didn't have to take a limit because both sides were exactly that number. That was number 11. Yeah. Okay, anybody think they have the answer on 12?
Three.
3? Okay, so how did you know? Because you are correct. The correct answer is 3. When we did this, you plug in 0, you would get f at 2, because the absolute value goes away. Then you'd have to know whether or not you're approaching 2 from the positive or negative side, because when we look at this 2, we get different values, whether we're approaching from the positive or negative side. So how did you know whether to approach 2 from the positive or the negative side?
Oh, I sort of did it differently. I just did the absolute
how did you
value
do?
at 0, which
Okay.
f at 0 is -1. So I did 1 plus 2, and then just got f at 3, which is 3.
Huh. I think you lucked out.
Really?
Because we typically cannot distribute, like, you can't distribute a function through the parentheses. So usually, like, f at 1, f at 3 is not equal to f at 1 plus f at 2. That was just a coincidence on this question. So here, let me just look and make sure. So yeah, we have to decide. We know we're approaching 2, because if we plug in 0, we'd have f at 2. But because at 2, there's this break, you have to know, were we approaching 2 from the positive or negative side? But we are approaching from the positive side, and this is kind of weird, because we have to think about the graph of the absolute value function. And the absolute value function, if we're approaching 0 from either side, we're approaching above. So that's why I have to put the plus sign right here. So that's how I know that I'm on the f function, approaching from the values bigger than 2. So I'd be approaching on this side, which is why I get that value of 3. Okay, so whenever there's like that discontinuity, a jump discontinuity, you have to kind of think through, could you be approaching the number from one side or the other? Okay, what about 13?
Wait, Ms. Brown.
Yeah. Was that Kaden? Did you have a question?
So you get 3 because, yeah, it's me. You get 3 because that's where the y value of the one approaching positive is. That's what you said.
Exactly, and you had to know, so we knew. So like at first we could just plug in 0, right, and this just goes away and we get 2. So at first I'd say f at 2, but because the graph has 2 values at 2, I had to think more clearly about it. I had to think, are we approaching 2 from the positive or negative side? So that's why I had to decide whether or not to approach 2 from the left, or from the right, or from the left. And that's where we had to look at the graph of the absolute value. The absolute value, if we're approaching from either side, those values are above. They're bigger than 2, so that's why I had to go the 2, just barely bigger than 2, so we had to approach on this side.
Okay, that makes sense.
Well, let's try 13. So I'm gonna try the easy way first. So I always try to see if I can just get by with just substituting. So if I just plug in 0, I would have g at 0 times f at 2. But again, when I have that f at 2, it makes me think, well, f at 2, well, in this case, it doesn't matter, because, let me make sure, yeah. sorry, I want to just take one look. They're breaking it up into looking at it on both sides, but both sides are the same, so I don't think there's an issue. What is G at 0? What is the limit? Because we're taking the limit. What is the limit of G at 0?
Two.
No, sorry, the value is 2. I'm gonna break this one up and show all of these intermediate steps that. So I'm going to take this to the other page because there are a few steps here we could look at. Okay, I'm going to get those graphs too. We need G and F. Okay, so because it gets a little bit confusing when we plug in the 0, we're going to get G at 0, which, you know, do we take the point or do we take the limit? And if we plug in 0, we'd have F at 2, but F at 2 again is a little confusing. So I'm going to actually break this up into the limit from the right and the limit from the left. So I'm going to consider the only way this would exist is if I take the limit as x approaches 0 from the positive side of this function. And then I'd have to compare this to the negative side. So I'm going to think about them individually. If I think about this as I approach 0 from the positive side, I'm just taking the limit of each piece. So I want to take the limit of G as we approach from the positive side. So because we're talking about a limit, as we approach, sorry, positive side is over here. As we approach 0 from the positive side, that's 0. So this piece is 0 because I'm talking about a limit. If I plug in 0 from the positive side, so that would mean I'm plugging in a value just barely bigger than 0. If I plug in a value just barely bigger than 0, like 0.1, then this would be like F at 2.1. And F at 2.1, if it's something just barely bigger, is 3. No, sorry guys, I'm doing a terrible job explaining. If I plug in 0.1, let me show my step and then it would make more sense. I'd have 0.1 plus 2. Well, 0.1 plus 2 would be 1.9. And the function at 1.9, at an x value of 1.9 is down here at -1. So this would be -1. But a 0 times anything is 0. So that limit is 0. And let's see if it can make a little more sense if we compare the other side. So now I'm going to do 0 from the negative side. So G of x times F at x plus 2. I guess one thing we could do is just from the beginning, just plug in a value of 0 that's just barely to the left. So I could plug in like -0.1. -0.1 is just barely to the left. And then I can plug that in instead. So I'd have G at -0.1 times F at -0.1 plus 2. So if we look at the graph, G at -0.1, but we're approaching. So if we're approaching here, as we get closer and closer, that goes to 0. So this is 0. This would be F at 1.9. Yeah.
Is 0.1 plus 2 1.9?
I was right on the other side. Thank you. I got these two mixed up. This would have been 2.1, right? And this one is 1.9. So 2.1 would have been 3. Not that this changes it, because when we multiply, so F at 2.1 would be here, has a value of 3. Anything gives us 0. But if we're at 1.9, if we're on the other side of 2, we get -1. But either way, we're timesing by 0, so we get 0. So if we can show we get the same thing from both sides, that's why this one is also 0. Thank you. Let's see if the last one is as bad. So on 14, we have this limit, and well, I guess J is right above. -2, so here's the issue. -2, do you see how we are, like we can't actually get to -2, we're approaching. So I'm going to break this one up into the same steps that I did the other one, and hopefully do a little bit better job of explaining. So let's do 14. I'm going to grab the graph as well. we can talk about this graph. I'm going to break this up into the limit from the right and the limit from the left. Okay, so I'm going to take the limit as we approach the -2 from the negative side. So one way of doing this is thinking, okay, you're approaching -2 from this side, so we want a number just barely on that side, which would be like -2.1. So let's see if we can plug in -2.1 and get something out. So this would give us j of j at -2.1. So looking at the graph, we're looking at j at -2.1. J at -2.1 goes to is what? Or as we get closer and closer, because remember we can get closer and closer. What does that approach? Would you guys agree that that piece is approaching infinity? We're good? So now this is really just asking us what's the limit as x approaches infinity of the j of x graph? Well, as we approach infinity, as we go to infinity, this graph approaches 2. So this limit is 2. So as we approached -2 from the negative side. Would it be different if I had approached the number -2 from the positive side? Would that have made any difference? So we'd have to go,
No.
yeah, we can see no, because if we approach from this side, we would have just been at like -1.9. But if we had been at -1.9, we would have j of j at -1.9. But in this picture, as we approach on this side, it still goes to infinity. So this piece still goes to infinity, which means we're considering the same limit as it goes to infinity, and we would also get 2. So because the left side equals the right side, this limit also equals 2.
How do you know
Okay.
when you plug the limit, or like why you
When
wouldn't
I have to do both sides.
for x?
If it gets a little confusing, so what I guess I didn't have to on this one, because if I had looked at it, I could see that both sides were approaching the same thing. So I could have just said, oh, well, I can see both are going to infinity. So I could just plug in infinity for this piece and know that it's 2. Versus one like this, when we plugged in 2, so f at 2, if I had just plugged in 0, I'd get f at 2. But f at 2, I can see that I actually get 2 different values depending on which side I'm approaching from. So if I had tried direct substitution, g at 0 times f, if I plugged in 0, I'd have f at 2. This is the place that gives me concern, because as I approach 2, one side goes to 3 and one side goes to 1. So that's why I would have to go, oh, okay, that's why I have to consider the left and the right. Does that kind of make sense? Okay, so I think that's the confusing part of your assignment. Let's do one more. So this next one asks us about a horizontal asymptote, and they want us to use a calculator. So I want to make sure we're comfortable using a calculator. So they want the horizontal asymptote of the function g of x. Oh, sorry, no, without using a calculator. Anytime you hear horizontal asymptote, what do we do for a horizontal asymptote? What is a horizontal, or no? Let me put this on a new piece of paper. Okay. How have we defined a horizontal asymptote? There's a definition, a limit definition of a horizontal asymptote. Anybody remember? It's a limit as what?
X approaches infinity.
Perfect. So if x approaches infinity, as long as you get a number out, that number is your horizontal asymptote. So it would be whatever that number is that you get. So anytime it's talking about a horizontal asymptote, you really just have to find a limit to positive or negative infinity. So I should say there could have been a plus or a minus in front of that infinity. So we're going to take the limit of g of x as x goes to infinity, and we should consider both. Often, though, they're the same. So I'll do positive infinity first. Okay, so we're going to have to consider that. We will also have to consider the limit as we go to negative infinity, because sometimes we have different horizontal asymptotes. So if we plug in infinity, if we were to plug in a large value, this is where we can consider end behavior. End behavior is these leading terms. Which of those is growing faster, x cubed or e to the x like, could I consider this top heavy, bottom heavy, or equal?
Bottom heavy.
Bottom heavy, good. E to the x grows faster, so this is bottom heavy, meaning the denominator is still going to be infinity. And when you divide by something that's bottom heavy, if the bottom gets really big, it always goes to 0. So bottom heavy is always 0. That tells us that we have a horizontal asymptote at y equals 0. Not too bad. Most of the time, positive infinity and negative infinity give you the same answer. E to the x, the reason why I knew I'd have to do something different here, I'd have to consider them both separate. Think of the graph of e to the x. E to the x behaves differently when you go to positive infinity versus when you go to negative infinity. As you go to positive infinity, yeah, e to the x goes to infinity, and it goes to infinity pretty quickly. But what is it as you go to negative infinity? What is the limit as x goes to negative infinity on the graph of e to the x? 0. Thank you, Lance. So as we go to negative infinity on this graph, it goes to 0. So if I plug this in, I'm really working with, let me just make sure this is, they didn't even make us go into this, but we're not going to get a number out because the denominator, if I go to 0, this piece is approaching 0, but the rest of it will approach the same thing. So this piece here goes to 0. So this would really be the same as saying the limit as x goes to negative infinity of x cubed plus x over x. So we can kind of ignore the e to the x. Then we can approach this the same way we have before with end behavior and say, okay, well, this end behavior function is x squared. So it would be the limit as x goes to negative infinity of x squared. But that's infinity, which is not a number. So that means there's no horizontal asymptote going that way because it had to be a number. Not terrible. So our only horizontal asymptote is y equals 0. Okay. Okay, how are you going to do 16 without using a calculator? What do you guys think? Anybody think they know the answer? What's our first thing we always try? Any limit problem, first thing we try.
Direct substitution.
Very good. So let's just see what happens. Let's try direct substitution. So we're just going to try plugging in 0. And we just hope we get out an answer. If we get out an answer, we're good. This is good trig practice. We get an opportunity to practice all our trig values. What is sine at 0 equal to?
0.
0. Very good. It's probably been a while, but what's anything to the 0 power?
1.
1. Good. So then that's 0 plus 2 because this is here is just 1. And then in the denominator, we have cosine at 0. What is cosine at 0?
1.
1. Perfect. Thank you. This is just 2 over 1, or we can say 2. So always try direct substitution first. That one was really just a chance to practice evaluating functions. Okay. So I think the rest of this assignment, I was going to do one other thing, but I'll save it for tomorrow. This one, 17, let's just get it set up. This is one that I would star. I can pretty much promise you, you will have one like this on your test. We've starred it every time we've seen it in this unit where you're asked to find it. I think this is the first time we've seen it where we have 3 functions. We've seen this question before in a piecewise, but with just 2 functions. So on 17, the difference is they want us to show that it's continuous, but we have to find 2 unknowns. We have to find A and B. This is how I think about it. I'm going to think, because I don't want to sketch this, it would take forever to sketch this graph. So I'm just going to kind of think of it on a number line. One function is defined for values less than -1, so I put -1 on here. One other function is defined in between -1 and +1. So because one function is defined there, I'm going to put +1 here. And then another function is defined for values greater than 1. So instead of sketching the picture, I'm just going to write the equation for each piece. So like for values less than -1, the graph would be x minus 1. in between -1 and 1, the function is ax plus b. For values bigger than 1, it's 2x plus 1. So I'm just basically seeing how these three pieces should fit together. It's supposed to be the a minus or ax plus b is, defined in between -1 and 1. So if I actually sketched this graph, I'd have some linear function, some other linear function, some other linear function, but I don't want to take the time to graph it. Now, organizing it like this, though, will help you realize that in order for this to be continuous, the two pieces that have the -1, these two pieces, must equal each other. So I'm going to start with my first equation being x minus 1 needs to equal ax plus b. Those two functions have to equal each other at the value they're supposed to meet. So they need to equal each other when x equals -1. So there's my first equation. Anytime you're solving for two variables, in this case, we have to solve for a and we have to solve for b, you need two equations. So the second equation is these two pieces have to equal each other. So we need the ax plus b must also equal the 2x plus 1. Those should equal each other at what x value when x equals what? 1. Very good, Hayden. We are at that because those are supposed to meet at 1. And again, that's because over here, both of those functions have the 1. So that's why I set those two pieces equal at 1. If you can make it to here, it's just algebra. So the rest of this question is just algebra. So if I do the green equation first, I'm going to replace x with a -1. So I'd have a -1 x plus b, no, sorry, -1a, or a -2 equals -a plus b. So I'll leave that one for a second. But again, back to just solving systems, if you have two unknowns, you need two equations. So that's where this second equation is going to come in. So now in this equation, I'm replacing x with 1. This would leave me with 1a plus b equals 2 plus 1, or a plus b equals 3. Not bad. Now it comes down to your two options that you have. Your two options are you can do substitution or elimination. I like elimination, so I'm going to take this green equation. I'm just going to write it below my purple one. I'm going to just switch the order. So I'm going to write it as -a plus b equals -2. So all I did was took this equation and I wrote it below that equation and just lined up the a, b, and the constant. Didn't change the order or anything. I basically just flipped it. Now I can add these two together. If I add them together, a minus a, that's 0. This is why we call it elimination. B plus b is 2b. So then 3 minus 2 gives us 1. What's our last step?
Solve for b.
Good. And so let's see, was that Caleb? After I solved for b, so now I have b equals 1/2. How are we going to find a?
Would you plug B in for B?
Good, good. Which equation do you want to plug it into, Sean? The purple one or the green one?
Let's do the green one.
Great. And it could be either one. So you just choose one. So the green equation was -a plus b equals -2. So we're just going to plug in that b value. So we'd have -a plus 1/2 equals -2. And we just solve for a. So if I minus 1/2, I'd have -a equals, let's see, that'd be a -2.5. Divide by a negative, so a is 2.5. Okay, so now we've solved for a and b. Okay, I believe you're going to see this question again on tomorrow's assignment, or this process again, so you'll get a chance to practice it again. But if you have 3 pieces, you have to come up with 2 equations and go from there. Okay, I believe the rest of this should go okay. 18 says use a calculator. There's an intermediate value. So if you are feeling pretty good, you can log out and just work on this on your own. I will stay here in the Google Meet though, so if you want to stick around and kind of work a problem and then ask questions, I'll be on here answering questions till the end of class, and class goes until 36, so we only have about 7 minutes, but if you want to stick around, I'll be on. Otherwise, I will see you guys tomorrow.
Thank you.
Thank you.
Yep, have a good day. And I'll post this document in case it's helpful.